Roman, making everyday objects robotically manipulable with 3D printable add-on mechanisms. My name is Jiahao and I work on these projects with Jeeun from HCIED lab at Texas A&M University and Alexis and Xiang from UCLA HCI Research. This work is partly sponsored by Adobe. Robots have been more and more popular in humans' daily life, such as vacuum cleaners, robotic toys, and assistive robots. Future robots are expected to provide physical assistance for the people at home that require the use of diverse tools and everyday objects. However, there are objects that are hard to be manipulated by robots. For example, robots may fail in the task of opening a door using a doorknob, or it requires advanced and dexterous robotic hand to perform the manipulation of a certain object. And there are also a bunch of handheld tools designed for humans that are hard to be manipulated by robotic arms. So what is Roman? Roman is a robotic design that aims to empower generic robotic arms with the ability to manipulate different types of everyday handheld tools with or without the help of human users. So such as this wire cutter, a low-cost robotic arm can use the robotic design provided by Roman to manipulate a wire cutter and help the human user to finish a wire cutting task. And now you may have the questions. Why is this wire cutter hard to be manipulated by a robotic arm? And how does Roman solve the problem? Let's take this wire cutter as an example. Imagine when a conventional robotic arm with a parallel gripper is trying to manipulate this wire cutter. It has to do two things. The first is to hold the wire cutter stably by gripping on the gripping points on the handle. The second is to apply a squeezing force on the handle of the wire cutter to perform the cutting action. However, the gripping of the wire cutter by the robotic arm is not stable because the gripping point is far away from the object's center of mass, and the gripping points are not relatively static, which may lead to a failure of the manipulation task. We also summarized other types of problems which may lead to the objects being not manipulable by robotic arms. And we conducted a categorization of robotic manipulability problems in everyday handheld objects. Please refer to our paper for more detailed information. Roman consists of a magnetic gripper and 3D printable mechanisms for different objects to solve the robotic manipulability problem. The magnetic gripper can be attached to any generic robotic arm, and the 3D printable mechanisms can be used to actuate different types of objects, such as squeezing motion of a plier or pumping motion of a hand sanitizer. The structure between the mechanisms and the gripper is used for securing, attaching, and detaching of the two parts and transfer the motion of the motor to actuate the mechanisms. Let's take a detailed look of the magnetic gripper first. It has the following major parts: an onboard processing unit, which is the Node MCU microcontroller. This is used for sending out command for manipulating different objects. The gripper has 4 magnets, as it uses magnetic force to securely grip the mechanisms. The gripper also has 2 motors. One motor is for actuating the mechanisms on the objects. The other is used for detaching the mechanisms by using the detaching bar. An RFID reader is also used for detecting the objects. Roman uses a pair of crown gears to transfer the motion from the motor to the mechanisms. As you can see, when the mechanism attaches to the gripper under the magnetic force, the crown gears could mesh with each other even if the teeth were not aligned initially. This feature could guarantee a successful attachment without the help of human users. Then the crown gears will transfer the rotary motion to the target motion of the mechanisms. The goal of the mechanism is to transfer the rotary motion of the motor output to different types of motion required to activate the objects. For example, the output of the gear rack is linear motion, and it could generate large enough force by decreasing the radius of the spur gears. Therefore, it is good for the objects such as the hand sanitizers, which require relatively large force to manipulate. Similarly, the output of pin slot is also linear motion. However, by adjusting the length of the pin, large speed can be achieved for performing tasks such as using the knife to cut chives. Differently, the output of the spur gear mechanism is the rotary motion. The goal of this mechanism is to translate the rotating axis of the motions. Also, by adjusting the radius of the two spur gears, different speed and torque can be achieved for different purposes. One example is to open a door using the doorknob. The other example is to rotate the handle of the can opener, which requires really large torque to open a can. The output of the bevel gear mechanism is also rotary motion similar to the spur gears. However, instead of translating the motion axis, bevel gear could rotate the moving axis. For example, the robotic arm could use the screwdriver from a different angle. For more technical details, more examples, limitations, and discussion, please refer to our paper. Thank you.